Bismillahirrahmanirrahim. Topic 7, matrices. We're still on subtopic 7.1. Okay, at the end of this lesson, students should be able to perform the operations on matrices. This one is about between two matrices, and define the transpose of a matrix and use its properties. Okay, let's go to the multiplications between two matrices. Okay, is the product of two matrices A and B is defined only when the numbers of column in A is equal to the number of row in B. Okay, so we can get the new order. If the order of A is m by n and the order of B is n by p, means that the result of the multiplications has the new order m by p. Okay, this is how it works. Matrix A multiply with matrix B, we can get the new matrix with the new order if and only if we have these two numbers are equal. The numbers of column for the matrix A must be equal with the numbers of row for the matrix B. So we can get the new order for the multiplication operations. Okay, this is the process. A row and a column must have the same number of entries in order to be multiplied. If not, the process will not happen. Okay, so in order to make the multiplication between two matrices, so this is the way multiplication of the row and a column. Okay, let's say we have these two matrices R and C. R is the row matrix, C is the column matrix. We have the same entries, same numbers of the entries. Okay, so the new matrix that we can get. Okay, so A, we have to multiply with the first element of the first column, A1 times with B1. For the second element, also have to multiply with the second element for the first column. Okay, so this is the way. Next, the third element of the first row must be multiplied with the third element of the first column. Okay, the multiplication must be between a row and a column. So we have this is the final solution that we can get, the result. Okay, let's see the first example. Okay, so we call it, this process is a dot product. Here the first row must be multiplied with the first column by using the dot product multiplications. Okay, first with the first, second with the second, and third with the third entries. Okay, this one from the first row. Okay, this one is for the first column, and then just total up so we can get 58. Okay, so in order to get the second entries for the first column, means that between second row and first row and second column here. Okay, this is in order to get the second entries for the first row. So first and second. Okay, because we want 1 and 2, first row, second column. Okay, so we can get total up we have 64. And for the other entries for the second row, this one, in order to get the second row, first column, this one second row and second column. Yeah, in order to get the entries for each of them. Okay, A and A to 1 and A to 2. So you can get A to 1 should be here and A to 2 should be here. So we can get this is the solution for example 1. 58, 64, 139 and 154. Okay, so let's go to the next example. Okay, find the multiplication between these two matrices. 1, 2, 3, negative 2, 0, 5, multiply with 2, 1, negative 3, 4, 2 and 1. So this is 2 by 3 matrix. This one is 3 by 2. Okay, so as you can see, so we have the same number here, column for the first matrix and row for the second matrix. So if these two numbers are equal, so we can proceed with the operations, multiplication operation for this matrix. Okay, this way, same as before. Okay, so first column, this one for entries of 1, 1. So means that first row, first column. Okay, so first row here and first column here. So you have to apply the dot product. 1 times 2. Okay, 1 times 2 plus 2 times 3 and then plus 3 times 2 here. You have all the multiplications and then just total up, so you can get the first entry for the new matrix. Okay, same for this one, you have A. This one is for the second element or second entries for the first row. So first and second. First row, okay, this is the first row and second column here. This is the second column. Okay, somewhere here. Okay, and then you should just do the same thing, multiplications for by using the dot product and then total up. So you can get this is the result: 2, 12, 6 and 3. Okay, example 3. Okay, let's check for the order first. Okay, so for A matrix, so we have 2 by 3, 2 column, sorry, 2 rows and 3 columns. Okay, for B, so we have 1, 2, 3, 3 row and we have 1, 2, 3, 4 column. Okay, now we have to check whether we can proceed with the process, the multiplication process or not. Okay, so look at with the numbers of column for the first matrix A, because we have to find A times B. Focus on A first, and then from B we check it for the numbers of row. So now we have these two are equal, so therefore we can proceed with the multiplication process. Okay, so this is the solutions. Okay, matrix A times with matrix B. A we have 2, -5 and 4 for the first column. We have 2, -5 and 4. Second row we have -1, 7 and 5. Okay, multiply with matrix B. We have 1, 3, 5 for the first column. 1, 3 and 5. Second column we have 2, -2 and 4. Next we have -3, 1 and 0. And the last column we have 5, 5 and 7. Okay, we have to use the dot product operations. First row multiply with the first column. Okay, same as before. Okay, in order to get the first entry for the new matrix, we have to multiply with this one. Okay, multiply these things, and then for the second entries for first row, multiply with the second entries for the first column, and then same as this one, third entries with the third entries. And then after we have multiplied this, and then just total up. Okay, so we can get same operation with the other entries, so you can get this is the answer. Okay, so let's say example 4. We have matrix A, 81, 2, 3 and 4. So this is 2 by 2. B, also we have 2 by 2. Now the question on you, we to find or to show whether A times B is equal to B times A or not. Okay, you have to show this statement. Okay, so check it for the rows. Okay, we have here 2 here, and this one also 2. So means that A times B, we can perform the operations. Okay, how about BA? So BA, so we need to check the numbers of column from matrix B. Okay, this one numbers column from matrix B. And numbers of row of matrix A. So also the same. So we can also perform these operations. So now we need to check whether the answer equal or not. So A times B, so we can get these things 4, 5, 18 and 5, and then by using the dot products operations, you find the operation of B multiplied with A. Okay, so we have -5, 0, 3 and 14. So now compare with the first answer, A times B. Okay, this is for A times B, the answer, and this one is the answer for B times A. So as again, not the same. So this result proves that the matrix multiplications is not commutative. Okay, so this is the properties of matrix multiplication that you have to know. Associative properties. Okay, it's up to you whether you would like to do B times C first, or maybe A times B first. Distributive. Okay, you have to total out first and then multiply with A, or maybe you want to expand first, multiply and total out. Should be equal for these two properties. Okay, let's see the transpose matrix. We have the definition for this transpose matrix. The transpose of a matrix A, so written as A superscript power P or A power by T is the matrix obtained by interchanging the row and column of A. That is, the ith column of A transpose will become the ith row of E for all i's. Okay, means that to transpose a matrix, we need to swap the row and column. Okay, we put these denotations in the top right hand corner to understand that we do the transposition process. Okay, see the diagram, what happened to the transposition operations. So as you can see here, okay, the first row, okay, this is the first row. After doing the transposition operations, become the first column. Okay, same as the second row. Okay, this is the second row, will become the second column. Exactly same as third row. A31, A32, A33 become third column of the transpositions matrix. Okay, let's see the example for these transposition operations. Okay, let be 213, then its operations become 213, but the difference is column become row matrix, column matrix become row matrix. Okay, then D, we have 3 by 3 matrix. Okay, the first row 1 3 3. Okay, so here 1 3 3. After transposition operations become 1 3 3, but it is column, not row anymore. Okay, example 5. Let's A, match of 1 2 3 4, and B, match of 3 4 to 1, and C, match of 1 4 3 2. Show that A, here these operations, A plus B, and then transpose equal to A transpose plus B transpose, and B, multiplication first, then transpose equal to C transpose multiplied with B transpose. So you have to prove that. You have to show that whether this statement true or not. Okay, this is the summations between A and B. So we can get 4 6 5 5. Then transpose these operations. So we get 4 5 6 5. Then we need the same thing for the right hand side. A transpose plus B transpose, transposition first and then additions process. So we have, after transposition, we have 1 3 2 4 plus 3 2 4 1. So we have 4 5 6 5, and check it with the first answer. So exactly the same. So we have shown that statement, the first statement is true. Okay, next, B, multiplication first. B times C. So by multiply these two matrix, so we can get 15, 20, 5, and 10. Then transpositions according to that segment. So become 15, 5, 20, and 10. Then the right hand sided multiplication between C transpose and B transpose. We need to transpose first. After that, multiplications operations. So we have 15, 5, 20, and 10. Then compare with the first answer just now. So exactly the same. Okay, basically this is the properties of transpose process or transpose operations. This is what they have to know. A plus or minus B transpositions must be equal to A transpose plus minus B transpose. So you can do whether summation or addition process first and then transpose, or you would like to transposition first and then followed by additions and or subtraction. For second properties, we have double transposition operations. A transpose and then transpose again, so back to the original matrix. Okay, then third, that we already proved it just now. And for multiplications between a matrix and a scalar, whether you would like to multiply first and then transpose, the answer should be equal to transpose the matrix first and then multiply with the scalar. Okay, one more thing they have to remember, these two is the different things. We already proved it just now. B times A is not equal to A times B. So exactly we can apply that rules for transposition operations. Okay, so this is the exercise. You can try on your own, try to solve all these questions. Okay, the answer already provided.